Section 1.7 Solving equations by multiplication and division. In this video, we will learn how to solve an equation by multiplying both sides of the equation by the same quantity, dividing both sides of the equation by the same quantity, the inverse operation of multiplication, and the inverse operation of division. In Section 1.6, we stated that two equations that have the same solutions are equivalent. Furthermore, we saw that adding the same number to both sides of an equation produces an equivalent equation. Similarly, subtracting the same number from both sides of an equation also produces an equivalent equation. We can make similar statements for multiplication and division. Multiplying both sides of an equation by the same quantity. Multiplying both sides of an equation by the same quantity does not change the solution set. That is, if A equals B, then multiplying both sides of the equation by C produces the equivalent equation A times C equals B times C, provided C is not equal to 0. A similar statement can be made about division. Dividing both sides of an equation by the same quantity does not change the solution set. That is, if A equals B, then dividing both sides of the equation by C produces the equivalent equation A divided by C equals B divided by C, provided C is not equal to 0. In Section 1.6, we saw that addition and subtraction were inverse operations. If you start with a number, add 4, and subtract 4, you're back to the original number. This concept also works for multiplication and division. Multiplication and division are inverse or opposite operations. Two extremely important observations. The inverse of multiplication is division. If we start with a number x and multiply by a number a, then dividing the result by the number a returns us to the original number x. In symbols, a times x divided by a equals x. The inverse of division is multiplication. If we start with a number x and divide by a number a, then multiplying the result by the number a returns us to the original number x. In symbols, a times x divided by a equals x. Because multiplication and division are opposite operations, we can undo multiplication with division, and vice versa, we can undo division with multiplication. Let's put these ideas to work. Example 1. Solve the equation 3x equals 24 for x. Solution. To undo the effects of multiplying by 3, we divide both sides of the equation by 3. So take the original equation, divide both sides by 3. 3x divided by 3 equals 24 divided by 3. Then 24 divided by 3 equals 8, which equals x. To check, substitute the solution 8 into the original equation. So let x equal 8, then 3 times 8 equals 24. Since both sides are equal, 8 is the true solution of the equation. Example 2. Solve the following equation for x. X divided by 7 equals 12. Solution. To undo the effects of dividing by 7, multiply both sides of the equation by 7. So take the original equation, multiply both sides by 7. Then, on the left, multiplying by 7 undoes the effect of dividing by 7 and returns us with x. And on the right, 7 times 12 equals 84. Solution. To check, substitute the solution 84 into the original equation. That is, let x equal 84. Then 84 divided by 7 is 12, and both sides are equal. Therefore, 84 is a true solution of the equation. Word problems. In Section 1.6, we introduce requirements for word problem solutions. Those requirements will be strictly adhered to in this section. Example 3. 15 times a certain number is 45. Find the unknown number. Solution. In our solution, we will carefully address each step of the requirements for word problem solutions. Step 1. Set up a variable dictionary. We can satisfy this requirement by simply stating, let x represent a certain number, the unknown in the problem. Step 2. Set up an equation. 15 times a certain number is 45. Becomes 15 times x, the certain number, is equal to 45. In step 3, we'll solve this equation. To undo the multiplication by 15, we'll divide both sides of the equation by 15. So on the left, dividing by 15 undoes the effect of multiplying by 15 and returns us with x, and on the right, 45 divided by 15 equals 3. Therefore, step 4, the answer to the question is the unknown number is 3. Looking back or checking, does the solution 3 satisfy the words of the original problem? We were told that 15 times a certain number is 45. Well, 15 times 3 is 45. Therefore, our solution is correct. Example 4. The area of a rectangle is 120 square feet. If the length of the rectangle is 12 feet, find the width of the rectangle. Solution. In our solution, we will carefully address each step of the requirements for word problem solutions. Step 1. Set up a variable dictionary. When geometry is involved, we can create our variable dictionary by labeling a carefully constructed diagram. With this thought in mind, we draw a rectangle, then label its length and width and area. The figure makes it clear that W represents the width of the rectangle. The figure also summarizes information needed for the solution. Set up an equation. We know that the area of a rectangle is found by multiplying its length and width. In symbols, area equals length times width. We are given the area is 120 feet squared, and the length is 12 feet. Substitute these numbers into the area formula, 1.1, to get area, or 120, equals length of 12 times the width, W. Step 3, solve this equation. To undo the operation of multiplication by 12, divide both sides of the equation by 12. So take the original equation, divide both sides by 12, then on the right, dividing by 12 undoes the effect of multiplying by 12 and returns W. Then on the left, 120 divided by 12 equals 10. So the answer to the question, the width, is 10 feet. Looking back or checking, does the found width satisfy the words of the original problem? We were told that the area is 120 square feet and the length is 12 feet. The area is found by multiplying the length and width, which gives us 12 feet times 10 feet, or 120 square feet. So the answer works. Example 5. A class of 23 students averaged 76 points on an exam. How many total points were accumulated by the class as a whole? Solution. In our solution, we will carefully address each step of the requirements for word problem solutions. Set up a variable dictionary. We can set up our variable dictionary by simply stating let T represent the total points accumulated by the class. Set up the equation. To find the average score on the exam, take the total points accumulated by the class, then divide by the number of students in the class in words and symbols. The total points divided by the number of students, which is 23, is equal to the average score of 76. An equivalent equation is T divided by 23 equals 76. Solve the equation. To undo the division by 23, multiply both sides of the equation by 23. So, the original equation, multiply both sides by 23, and on the left, multiplying by 23 undoes the effect of dividing by 23, and returns T. On the right, 76 times 23 is 1,748. So the answer to the question, the total points accumulated by the class on the exam, is 1,748 points. Looking back or checking, does the solution 1,748 points satisfy the words of the original problem? To find the average on the exam, divide the total points by 23, the number of students in the class. Note that this gives an average score of 1,748 divided by 23 equals 76. Therefore, the answer works.